Hello guys, good evening. So today we are going to start our next chapter, that is coordination chemistry. So before starting coordination chemistry, see, as the name suggests, coordination compounds, the chapter name is coordination compounds. So first tell me, what is coordination compound? Can you define it? So coordination compound is one. Yes, coordination compound. So what is a coordination compound? First of all, there is a coordinate bond in it. Definitely there is a coordinate bond. But what is the technical definition of coordination compounds? So actually coordination compounds are the molecular compounds which are resulting from molecular is a molecular compound resulting from the combination of two or more stable compounds. Okay, and it retains its identity in the solid state as well as in the solution. Okay, and its properties are totally different from the constituents present. For example, let us say we have FeCN twice. Okay, this is one of the compound. It is a stable compound. Now we mix it with potassium cyanide. It is also a stable compound. Okay, now when we mix ferrous cyanide and potassium cyanide in a china dish or beaker, whatever you have, and evaporate it to dryness. So on evaporation, what would happen? It forms compound like this, A4FeCN6, okay, which is called potassium ferrocyanide. So this potassium ferrocyanide, okay, this residue left is a well-known compound that is called potassium ferrocyanide, and it has a different name in the coordination chemistry. Now this coordination compound, there is an ionic bond between potassium and this whole thing. So it is 4K plus aqueous plus FeCN6 4 negative. Okay, so say in first case, say there is Fe2 plus ion, cyanide ion, potassium ion. Okay, these are the species. But when the species enclosed in this square bracket, this is called complex ion. What we call it as complex ion, and it is found to be very stable, and it does not give test of Fe2 plus or Cn negative. Okay, neither Cn negative nor Fe2 plus will give the test. So potassium ferrocyanide, it is used to test the presence of Fe3 plus ion in the mixture. But whenever this whole thing is present, if we have F ferrous cyanide, it will give test of Fe2 plus and cyanide ion. If we have potassium cyanide, it will give test of potassium ion and cyanide ion. But when they are mixed and heated or evaporated to dryness, we get this compound, then it will not give test of Fe2 plus or cyanide ion. Why? Because it form a complex ion, and this complex ion, in this complex ion, sorry but wait, sorry beta. So Fa2 plus ion, it forms coordinate bond with cyanide ion. So that's why it is called coordination compound, and they are attached by the coordinate bond. That's why it will not give test of Fe2 plus or Cn negative. They are not ionized actually. Okay, so we can write it like there are 6 negative and 2 positive. Okay, so there is 4 negative ion. Got it? So this compound is formed from the combination of two stable compounds. Okay, and it retains its identity in the solid state as well as in the solution. See this thing FaCN6, it retains its identity in solid state as well as in the solution, and its properties are totally different from the constituents present. Because in constituents, say we have ferrous cyanide, it will give test of ferrous ion, cyanide ion. Potassium cyanide, it will give test of potassium ion, cyanide ion. But when this complex is formed, it will give test of potassium ion only. Okay, it will not give test of Fe2 plus and cyanide ion, right? So this is the definition of coordination compound. That coordination compound is resulting from the combination of two or more stable molecular compounds, and it retains its identity in the solid state as well as in the solution, and its properties are totally different from the constituents present. Okay, and these are generally formed by transition metals. Coordination compounds are generally formed by transition metals or ions. Okay, transition metals or ions. Okay, now because why transition metals and ions are generally taken into account? Because they have vacant orbitals. Because vacant orbitals are required to accommodate electrons. Okay, so electron donor species can be easily attached to transition metals. Even inner transition elements, they have comparatively less tendency to form these complexes. Okay, because most of them are generally radioactive, and less stable. But in most of the cases, transition metal and transition metal ions, they are involved in coordination compounds. They are involved in formation of coordination compounds. Okay, got it? Now let us see the difference. What is the difference between coordination compound and double salt? See, I stated earlier that a molecular compound which is resulting from the combination of two or more stable molecular compounds, that is called coordination compound. So what about double salt? Double salts are also formed by the combination of two different compounds, two or more different compounds. Okay, because for example, let us take example, we have potassium sulfate, it is mixed with aluminium sulfate. Okay, and then it is slightly heated, so we get A2SO4 dot Al2SO4 thrice dot 24H2. What is this? Tell me. What is the name of this compound? Tell me, beta. What is the name of this compound? What is this? So double salts जो है, that is another class of compounds that are formed in the same way as the coordination compounds by mixing together the saturated solutions of two different compounds and evaporating to dryness. Same is the case with coordination compounds. Okay, they are also formed by heating or by evaporating to dryness. Yes, it is potash alum. Very good, beta. It is potash alum. Okay. So they are mostly crystalline salts. Generally, they are crystalline salts. For example, this is potash alum. Yes, what is more salt? Can you name? Can you write the molecular formula? More salt, ferric alum. This is potash alum. Okay. Chrome alum. So more salt is ferrous sulfate, ammonium sulfate dot 6H2. And what is ferric alum? Ferric alum, ammonium sulfate ferric sulfate 24H2, potassium sulfate, chromium sulfate dot 24H2. So these are all double salts. Now, it's say potash alum is formed by mixing two solutions of saturated solutions of potassium sulfate, two compounds, okay, and evaporated to dryness. In the same way, we prepared this one, potassium ferrocyanide, okay, but it gives characteristics of all the ions that are released in aqueous solution. So in potash alum, you know, this is potash alum. So potash alum give test of each ion. See, there are two potassium ions. There are three, two only. Two aluminium 3 plus ions. Then 4 sulfate ions. 24 H2O. Okay. So this clearly shows that coordination compounds represent a special class of compounds which differ in the nature of bonding from double salts and other molecular compounds. Okay. You know, coordination compounds retain their identity in solution, whereas double salt lose the same. See, coordination compound retain its identity in both in solid state as well as in solution. But double salt loses its identity in solution. Okay. So I think you got the idea what is the difference between a coordination compound and double salt. Both are formed by two or more salts. Okay, mixing of two or more salts and evaporated to dryness. But one retains its identity in solid state as well as in solution state. But double salt loses its identity. So let us try to figure out the difference between double salt and coordination compounds. Difference between double salt and coordination compound. So tell me, first difference between double salt and coordination compound. So double salts, tell me. So double salts are normally formed, yes, by mixing, yes, mixing in equal proportion, salts in equal proportion. From two salts in equimolar proportions. From their solution. Okay, and coordination compounds, they are also formed by mixing the salts, but the salts may or may not be in the equal proportions. Okay, very good, Sahil. So double salts, they exist only in solid state. Double salt exists only in solid state. And in aqueous solution, they dissociate into ions. They dissociate into ions, right? And what about coordination compounds? Coordination compounds, they do not lose their identity. They do not lose their identity, as we have discussed right now. They do not lose their identity in the solid state as well as in aqueous solution, because they do not dissociate into ions. The coordination complex is that one, FeCN6 4 negative, okay? That will not dissociate into Fe2 plus and Cn negative ion, okay? So they do not lose their identity. But double salt lose its identity in aqueous solution, okay? In this case, in double salts, constituting salts are ionic in nature. But in this case, the complex part, species present are linked with the metal ion by coordinate bond. In this case, in the complex part, species present are linked with metal atom or ion by coordinate bonds. Okay. Then, as Sahil said, the properties of the double salts are of the constituting ions. The properties of the double salt are of those of the constituting ions present. Okay, but properties of complex part, that is enclosed in square bracket, are quite different from those of the constituent present. Any other property? In double salt, metal show its normal valency. Okay, but in coordination compounds, they are quite different. Okay, right? So this is about the difference between double salt and coordination compounds. Okay, double salts have the same properties as that of the metal ions or ions present in the different salts, but coordination compounds properties are entirely different. Okay, even valencies are different. Now, some definitions of means important terms used in coordination compounds. First is coordination complex. Coordination complex, or we can say entity. Ashish, 2 marks. You should write 4 points at least. Okay, okay, coordination complex. So coordination complex or entity, that is the species enclosed in square bracket. It is also called coordination sphere. Okay, so coordination complex, entity or coordination sphere, it is what? It contains in it a metal ion, a metal atom or ion in which a fixed number of neutral molecules or ions, they are capable of donating electron pairs, are linked with coordinate bond. For example, CONH3 6. So this is a cationic complex, and these complexes may be cationic, anionic, or sometimes neutral. For example, FeCN6 4 negative or NiCO4. Okay, and just fixed number of ions or even molecules, like this. See, NH3 is a molecule, so CO3 positive Okay, so this is the coordination complex or coordination sphere. Yes, cobalt ion is surrounded by not by 6 nitrogen atom beta, 6 ammonia molecules. You can say 6 ammonia molecules, because the molecules or ions attached to the metal ion are those which should have at least one lone pair, so that they can form a coordinate bond. Okay, like NiCO4. Right? So complex, or we can say coordination complex, it may be cationic complex, anionic complex, or sometimes neutral complex. Okay, means if net charge is 0, that is called neutral complex. So this is about coordination complex or coordination entity or coordination sphere. Now second, central atom or ion. Central atom or ion. So in the coordination complex or entity, metal atom or ion to which a fixed number of molecules are attached by coordinate bond, that is called central atom or ion. See, in here you can see this one, cobalt. In first case, cobalt, CO3 plus. So this CO3 plus, 6 ammonia molecules are directly attached to it, okay, by coordinate bond. In FeCN6, Fe2 plus, okay, cyanide ions are 6 cyanide ions are attached to Fe2 plus. In NiCO4, carbonyl group, 4 carbon groups are attached to the nickel by coordinate bond. So these metal ions in which fixed number of molecules or ions are attached by coordinate bond, that is called central metal atom or ions. right? These are central atom or ion. And this central metal atom or ion, it is regarded as Lewis acid because it accepts the electron pair. Okay, and they accept electron from donor species. Donor species, they are called ligands and they are Lewis bases. So third term is ligands. Ligands, or we can say electron donor species. Okay, ligands or electron donor species. So ligands are actually electron donor molecules or ions in which either neutral, these ligands may be neutral, or anionic. Okay, neutral or anionic, because if they are neutral they should have a lone pair. Okay, so that they are linked to the metal ion by coordinate bond. There should be a coordinate bond formation between the metal and the ligand, and where ligand is donor and metal is acceptor. Okay, got it? And these electron pairs are provided by they are provided by ligands. Okay, and ligands are actually they are Lewis bases. Okay, so ligands are also known as dentates. They are also known as dentates. Okay, dentate means teeth. Dentate means denture, teeth. So they may be compared to teeth since they are surrounding the metal atom or ion in the same way as teeth have surrounded the tongue. Okay, so there are different types of ligands. They may have one teeth, 2, 3, so on. Okay, so let us discuss the types of ligands. So actually, what is ligand? Ligand is neutral or anionic, whatever, electron donor species. Ligand is a electron donor species. Okay, so let us discuss types of ligands. So atom or ion which donates the electron pair in the ligand, that is called donor atom or ion. So depending upon the number of such donor atoms or ions present, that is available for coordination, ligands have been classified into unidentate, so as the name suggests, unidentate, or we can call it as monodentate. Unidentate or monodentate ligands. So they have one donor atom with a lone pair of electrons, and it may be neutral or anionic. They have only one electron pair for donation. So neutral like water. See, it has two lone pairs, but only one can be donated. Ammonia, even triphenylphosphine. So they are neutral monodentate ligands. Now anionic. Anionic like OH negative, Cn negative, any halide, even nitrate, nitrite, okay, ONO negative, even acetate ion. So they are all monodentate ligands, anionic monodentate ligands. Got it? Next, bidentate ligands. So what do you mean by bidentate ligands? Yes, what do you mean by bidentate ligands? Bidentate or didentate ligands. So these are the ligands which have two donor atoms and have the ability, yes, to link with the central metal atom or ion at two positions. See, this is oxalate ion. It can also be represented as COO negative. This is oxalate ion. Yes, beta, Ashish, good. Good, Sad. Then, so it has two donor sites, okay? This one, ethane 1,2 diamine, okay? EN, है ना? Oxalate ion, OX. Then this is glycinate ion. GLY, okay? Even sulfate ion. Sulfate ion, even carbonate ion. So these are all bidentate ligands. Even, yes, very important, DMG, dimethyl glyoxime. Dimethyl glyoxime. DMG, it is used to test nickel. DMG test for nickel. Okay, good. So say if there are two lone pairs, okay, say in water there are two lone pairs, okay, but it cannot donate two lone pairs, okay, or even if two lone pairs are present on the same atom, it will never donate both at the same time, okay. So there must be two donor atoms present in it. There must be two donor atoms, not two lone pair on the same atom, okay. So it is not a bidentate ligand, it is only monodentate, because there are two lone pairs, but both the lone pairs are on the same atom. Okay, Next is polydentate ligands. So polydentate ligand means a ligand with more than two donor atoms. That is called polydentate ligand. Sometimes there are flexidentate ligand. Flexidentate means which can donate means flexibly. Which and there are two mean more number of donor atom, but few will donate pair of electrons. For example, yes, very good, Harshil. EDTA, best example. EDTA. So EDTA is ethylene diamine tetraacetate. Ethylene diamine tetraacetate. And that is EDTA. Okay. Hexadentate ligand. Right? There is one donor atom, two donor atom, 3, 4, 5 and 6. So there are total 6 donor atoms. So that is called hexadentate. Likewise, there are pentadentate, tetradentate, tridentate. Okay, done. So these are polydentate ligands. Yes. Now chelation and denticity. Chelation and denticity. So if the ligands with two or more donor atom groups, they are positioned in such a way that they form 5 or 6 membered ring with the center metal ion, then ligands are called chelating ligands. What I said, that there are, like, see, we have ethylene diamine. Okay, so in ethylene diamine, if it is attached to metal, okay, let us say platinum. So in this complex, say these donor atoms, they are positioned in such a way that they form 1, 2, 3, 4, 5 membered ring. Means if they are positioned in such a way, means donor atoms donor atoms are or groups, they are positioned in such a way that they form 5 or 6 membered ring. With central metal ion. Then the ligands are known as chelating ligands, and the ring formed is called chelate ring. That ring formed is called chelate ring, and that complex which is just formed is called chelate or metal chelate. Okay, and this property is called chelation. This whole property is called chelation. Okay, so word chelate, okay, that is means generated from Greek word chele, means claw. chelating ligands, they hold the metal atom or ion like a claw. So there are few examples. This is one of the example where 5-membered ring is formed. Okay. See, if we have EDTA, okay, let us say any metal, okay, not magnesium only, let us say any metal, okay. So any metal or metal ion is there, and ethylene diamine. See, ethylene, diamine, okay. So in this way, this is one of the acetate ion. Second acetate ion. Third. So this is the complex form. So see, there are 5-membered rings. 1, 2, 3, 4 and 5. 5-membered ring is formed. Now come to this. 1, 2, 3, 4, 5. All 5-membered rings are formed. Okay, so that is also a chelate. So that is metal EDTA. Okay, got it? So this is the concept of chelation. So there are hexadentate chelation, there are bidentate chelation, there are tridentate chelations, tetradentate chelations. There are different types of chelations. Okay. And what is denticity? Yes, what is denticity? Denticity means how many coordinate bonds are formed by the given ligand. Okay. So chelation, chelating ligand, metal chelate or chelate, these are the terms. Okay. Then what is chelate effect? Chelate effect. So chelates are more stable than the ordinary molecules. That is called, and they are more stable than ordinary molecules, and this stabilization of coordination compounds is due to chelation, and that is called chelate effect. I said chelates are more stable than ordinary molecules, and the stabilization is due to stabilization of a coordination compound is due to chelation. The stabilization of coordination compound due to chelation is called chelate effect. Okay, and these are quite useful in industry as well as in the lab. Like they are employed in the softening of hard water. In hard water there is calcium and magnesium salt. So EDTA used to remove calcium and magnesium because they form complex with calcium and magnesium, and that's why it is used for the softening of hard water. Okay, even the separation of lanthanoids and actinoids, even they are also find application in the detection or estimation of some metal ions like nickel. Nickel DMG complex is formed. Okay, even copper, magnesium, right? So this is chelation, chelate effect, and chelating ligand. Understood? Did you understand this? What is chelating ligand or chelation? First, what is chelating ligand? What is chelation? And third, what is chelate effect? Because that part is important actually. Yes, tell me. Did you understand this? What is chelating ligand? Those ligands which are in which two or more donor groups, they are positioned in such a way that they form 5 or 6 membered rings with the metal ion. That is called a chelating ligand. Okay, and that ring formed is called chelate ring, and that complex formed is called metal chelate, and this property is called chelation. And those chelates, they are more stable than ordinary molecules or ordinary compounds, okay, or complexes. These chelates or metal chelates are more stable than ordinary complexes, and that stabilization of those coordination compounds is due to chelation, and that is called chelate effect. Okay, so that's all for the day. Thank you very much for watching this video. Do like, subscribe and share my channel. Jai Hind, Jai Bharat.